course, WAN Troubleshooting. Troubleshooting WANs can be tough at times because you don't control and own the physical lines. You definitely don't receive the trouble tickets and stressful emails, but you're relying on someone else to do their job, and you have limited visibility in a lot of areas. However, that doesn't mean you're powerless, but it does mean that you've got to narrow the problem down to make sure you're working on the correct issue. A loss of internet connectivity. The most common trouble ticket you'll receive is someone complaining about not being able to connect to the internet. This issue can be caused by the WAN link dropping, the CSU, DSU or internal wiring, but most of the time it's due to an ISP issue. This doesn't mean you don't need to check your local physical WAN connections though. A better approach is to double check all your power to all devices including the smart jack and run a loopback test from the router to the CSU DSU to verify that specific links come up locally. Figure 1612 shows the different spots you would typically need to check out. Interface errors monitoring. There are a couple of key interfaces you need to check when verifying your WAN. If you have cable or DSL, you'll need to check into interface errors on the LAN port connecting to your router first. Let's take a look at an example to clarify how to use this information for interface monitoring to scrutinize errors, utilization discards, packet drops, interface assets and duplex issues. Router SHINTFA0/0 fast Ethernet 0/0 is up, line protocol is up. Output cut, full duplex 100 MB, 100 base TXFX ARP type, ARPA ARP timeout F4000. Last input 000005 input 000001 input hang never last, clearance of show interface counter never, input Q 0/75/0/0 size max drop flushes, total output drops 0, queuing strategy FIFO 0, QQ 0, output Q 0/40 size max 5-minute input rate 0 Mbps sec, 0 packets sec, 5-minute output rate 0 bits sec, 0 packets sec, 1325 packets input, 157823 bytes received, 1157 broadcasts, 0 IP multicasts, 0 runs, 0 joins, 0 throttles, 0 inputs, 0 CRC, 0 frame, 0 overrun, 0 ignored, 0 watchdog, 0 input packets with dribble condition detected, 2294 packets output, 24460 bytes, 0 underruns, 0 output errors, 0 collisions, 3 interface resets, 347 unknown protocol drops, 0 babble, 0 late collisions, 0 deferred, 4 lost carrier, 0 no carrier, 0 output buffer failures, 0 output buffer swapped out. Link status. The first thing we'll check when there is a trouble ticket on our network management tool alert us of a link error in the link status. The first line in the output is shown. This would be the same on a serial link as it is on Ethernet links. Our router SHINTFA0/0 fast Ethernet 0/0 is up, line protocol is up. The first up listed is carrier detect. It shows, if this shows down, then you have a physical layer problem locally and you need to to get to that port stat and check the cable and port. The second statistic, which is protocol, is up in this example is keep alive from the remote end. If you see up, down, then you know your local end is good, but you're not getting a digital signal from the remote end. You've got to be able to analyze interface statistics to find problems there if they exist. So let's pick up the important factors relevant to meeting that challenge effectively now. Speed and duplex settings. Make a mental note that the most common cause of interface errors is a mismatched duplex mode between two ends of an Ethernet link. This is why it's so vital to verify that the switch and its host PCs, router interfaces, cable modems and so on all have the same speed setting. If they don't, they just won't connect, and if they have mismatched duplex settings, you'll receive a legion of errors which cause nasty performance issues, intermittent connectivity, and sometimes even a total loss of communication. A common strategy is to use auto negotiation for speed and duplex, and it's enabled by default. But if this fails for some reason, you'll have to set the configuration manually like this. Router config int gi04/1, router config if speed 10 force 10 mbps operation, 100 force 100 mbps operation, 1000 force 1000 mbps operation. Auto enable auto speed configuration, router config speed 1000, router config if duplex auto enable auto duplex configuration, full force duplex operation, half force half duplex operation, router config duplex full. If you have a duplex mismatch, a telling sign is that the late collision counter will increment. Input queue drops. If the input queue drop counter increments, this tells you that more traffic is being delivered to the router than it can process. If the value is consistently high, try to determine exactly when these counters are increasing and how the events relate to CPU usage. Know that you'll see the ignored and throttle counters increment as well. Output queue drops. This counter indicates that packets were dropped due to interface congestion, leading to loss of data and queuing delays. When this occurs, applications like VoIP will experience performance issues. If you observe this constantly incrementing, consider QoS as a culprit, and QoS is quality of service. Input errors. Input errors often indicate high level errors such as CRCs, that's cyclical redundancy check. This can point to cabling problems, hardware issues or duplex mismatches. Output errors. This issue equals the total number of frames that the port tried to transmit when an issue such as a collision occurred. These errors can also be caused by interference on the line itself, which means you have to call the ISP to sort them out. On serial interface, start by checking out the physical connection to your router. Are you receiving clocking? This comes from the CESU, DSU. Check the output to see how to do that. Router SH controllers S04/0 interface serial 04/0. Hardware is power QUICC MPC 860 DTEV 35TX and RX clocks detected. Okay, we verified we're receiving clocking, so let's move on at what the interface is telling us. Router SHINT S04/0 serial 04/0 is up, line protocol is down. Hardware power QUICC serial description connection CR1 internet address is 192.168.11.14/24 MTU 1500 bytes BW 1000 KB DLY 20000 USEC reliability 255/255 TX upload 1/255 RX load 1/255 encapsulation PPP LCP closed loop back not set keep alive set 10 sec CRC checking enabled last input never output hang never last clearing of show interface counters 00:02:58 input queue 0/75/0/0 size max drops flushes total output drops 0 queuing strategy FIFO queue output 0/40 size max 5-minute input rate 0 bits sec 0 packets /sec 5-minute output rate 0 bits sec 0 packets sec 0 packets input 0 bytes 0 no buffer received 0 broadcast 0 run 0 giant 0 throttles 1565789 input error 0 CRC 0 frame 0 overrun 0 ignored 0 abort 0 packet input 0 byte 0 underruns 0 output errors 0 collisions 2 interface resets 0 output buffer failures 0 output buffer swapped out 0 carrier transitions DCD up DSR up DTR up RST up CST up. So I'm going to leave it here today for this video. If you like, listen, give me a thumbs up and please consider like, sharing and subscribing. Thank you.